Good afternoon, Robert Scribbler. It is August 13th, 2019. Thank you for joining me for another of my climate change and clean energy video blogs. Now, for this segment, what I am going to do is talk about the impacts of a record hot summer on the Arctic system and the Arctic environment. And in particular, we're going to talk about Arctic temperatures. We're going to talk about Arctic ice and related Arctic ice melt, as well as Arctic fires. Now, the months of June and likely July were the hottest Junes and hottest Julys ever recorded in the global climate record. And because of a process called polar amplification, in which the polar regions of the world tend to warm up faster than the lower latitude and middle latitude regions, much of the high temperature anomalies or departures from normal temperatures that we have seen over the past few months, past couple of months during these record hot periods, have focused on both the Arctic and the Antarctic. And you can see this in this temperature anomaly map provided by Moihu, the Moihu blog, which is over here, and is Moihu is a good tracker of potential temperature change, a good early tracker of potential temperatures for upcoming months. So Moihu is one of the places to go to if you are interested in early indicators for the upcoming month prior to the major monitors coming out with their official data, such as NASA or the JAXA or the Met Office, for example. And according to Moihu's analysis of global temperature, July was also a record hot month globally. And as you can see in this anomaly map, a lot of the anomalies focused on the northern hemisphere polar region and the southern hemisphere polar region. In particular, the southern hemisphere polar region looks to have been extraordinarily warmer than normal in the anomaly scale for this month. Of course, this is southern hemisphere winter, so actual temperatures are rather cold, but the change from normal is extraordinary, such that we see considerable warming during the winter, during the southern hemisphere winter, during the month of July in 2019. Now, the colder, darker regions of the globe tend to heat up fastest, and the colder, darker periods of time tend to show the greatest temperature gain. And this is overall due to the greenhouse effect acting like a blanket on the surface of the Earth and more evenly spreading out the heat gain for the Earth's surface coming in from solar radiation and being trapped and spread out by those greenhouse gases. So because the blanket of the greenhouse effect spreads the heat gain more evenly, you get that increase in temperature in the colder and darker regions and periods of time, more so than you would tend to see them in the brighter, typically warmer periods. And this is an effect that tends to produce the polar amplification that we see, or the more rapid polar warming that we see. There are other effects that are ongoing that also add to the polar amplification cycle, but one of the main ones is the more even spread of the incoming solar radiative heat forcing due to the greenhouse effect. Now, in the northern hemisphere, we also saw much warmer than typical temperatures for northern hemisphere summer conditions in the Arctic. And because it's during the summer, this is a bit more atypical, that you don't tend to see as high departures from normal during northern hemisphere summer in the northern polar regions. And this is due to a number of effects, such as the Ice Albedo Effect, which is more comes more into play during summertime. So as the sun increases in angle and the duration of periods in which the sun shines on the Arctic increases, you have more of that sunlight reflected back into space from the reflective ice surfaces. And the Arctic Ocean itself also provides a moderating influence, both due to the fact that it takes a lot longer to heat up ocean water than it does to heat up a landmass. But in addition, you also get more evaporative cooling coming from the surface of the ocean system. So the types of anomalies that we tend to see during summertime in the northern polar region are lower than the anomalies we tend to see during wintertime. And so the anomalies that we're seeing during June and July of 2019 stand out even more because of this moderating influence. And what we saw were some really considerable temperature readings. For one, Alaska experienced its hottest July on record, according to NOAA's, the National Oceanic and Atmospheric Administration's climate monitor. And in particular, we saw record heat for large portions of Alaska. Anchorage, as an example, experienced 90-degree temperatures during this period, and the 90-degree temperature was an all-time record for Anchorage. So very hot, hot conditions for Alaska, an Arctic or a near Arctic zone. Now, looking at some temperatures that occurred during the month of July, I'm just looking at an Earth Nullskull global forecast system model map of temperatures, not anomalies, but temperatures, direct temperature readings at the surface of the Earth. And these are 2-hour average temperatures, so it's not really completely getting the peak heating for the day. And I'm also looking at a region that has been very heavily impacted by wildfires, and this is northern Siberia. Now, drivers for wildfires in the far north and in the Arctic are, in particular, increasing temperature in the Arctic region. The Arctic is warming up much faster than the rest of the globe. And this increasing temperature is thawing out the permafrost, and during dry periods it creates piles of peat-like material or peat from this thawed permafrost that is also dry, and this dry material is an added fuel for wildfires. In addition, the increased heat produces more lightning strikes, which are more ignition sources for wildfires on top of typical human error-based ignition sources. So you have more fuel, more heat, in some cases more dry conditions that come along with the heat, and more lightning strikes. All of these are a combined effect that increases the risk of wildfires. I'm going to talk more about Arctic wildfires as we go along, but I would like to point out some of these temperature readings in the Arctic zone. This is a 67-degree north latitude reading of 83 degrees Fahrenheit, or a 28.2 degrees Celsius reading, and this is pretty far to the north. We also have some close to 85-degree readings in the near 68-degree north latitude zone, and that's north of the Arctic Circle. And this is very extreme temperature departures for July so far to the north. Even if you go just a little bit to the south here into more central Siberia, you're getting 90-degree readings at the 58.5-degree north latitude zone. So much hotter than normal temperatures in the Arctic and in the near Arctic during July, and in regions that are now and for much of summer have experienced very intense, in many cases unprecedented wildfire activity. And I'm going to show you some satellite shots of that activity. Now, going into the present day, I just want to show you how these abnormally hot temperatures have persisted in the far north, and it's worth noting that today, and this is a live view of the GFS model run. that the temperatures in the far north, close to the Arctic Ocean's shore, are hotter than temperatures in central Siberia at present, due to kind of a weird ridge trough formation. It's kind of an upside down ridge trough formation, which is bringing a lot of heat up into the Arctic and pushing some cooler air down, so generating a pretty severe dipole temperature pattern. So in central Siberia, well to the south along the 57-degree north latitude line, we've got temperatures in the 40s degrees Fahrenheit, or around 8.6 degrees Celsius, in the upper 40s degrees Fahrenheit range. But if you go north, above the Arctic Circle, you've got temperatures near the 80-degree mark at the 69.4 degree north latitude range, and even running all the way up to the Arctic Ocean shore along the Laptev Sea near 80-degree Fahrenheit temperature readings, or 77.1 degrees Fahrenheit, directly on the shores of the Arctic Ocean. This is much, much hotter than typical conditions for this region. If you go back a couple of decades, this whole region of the Laptev Sea was typically ice-locked at this time of year. So we're going to look at some satellite shots and some views of sea ice coming up. But I just want to impress on you how extraordinary the heat that we have seen in the Arctic, not just in Siberia, but all throughout the Arctic this year, in places like Greenland, in places like Alaska, which also saw 2 million square miles of forest burned through northern and Arctic wildfires, and in Scandinavia. So all the way around the Arctic Circle and the near Arctic region, we saw much, much warmer and much, much hotter than typical temperatures. And this is all driven by human-forced climate change, the climate crisis, which is in large part, in mass majority, being driven by fossil fuel burning in the region of generally overall emitting about 40 billion tons of carbon dioxide equivalent greenhouse gas into the atmosphere every year, which is just unprecedented even on geological timescales. And that's the primary driver of this global heating crisis that we are seeing today. Now, before we go on to sea ice, I'd just like to talk a little bit about the forecast. According to a GFS model produced by Karsten Haustein, who's produced this climate reanalysis site that looks at global temperature anomalies and forecast global temperature anomalies, it does look like the extreme Siberian heat that we are seeing at present is expected to persist over the next 7 days, as well as much warmer or hotter than normal temperatures in the Canadian archipelago and in the Baffin Bay region. Greenland gets a bit of a respite, which is a good thing after such a severe melt spike over recent weeks, and northern Canada also gets a bit of a respite. But overall, the Arctic region above the 66-degree north latitude line is expected to be about 1.3 degrees Celsius above normal over the next 7 days. This is, again, a high departure for this time of year, which typically tends to see more moderation in temperature anomalies. Now, moving on to Arctic sea ice and Arctic ice melt during the recent summer period of global record heat. We have seen record low Arctic sea ice extents, and we have seen record melt pulses in Greenland. And I'm going to start out with Arctic sea ice and the present condition of Arctic sea ice. Now, this monitor is a concentration map produced by the University of Bremen. And what it's showing at present is a much reduced Arctic sea ice extent with very low concentrations around the edge zone, particularly as we get in the region bordering the Laptev, the East Siberian, and the Beaufort Seas. And so over the coming days, we are likely to see these lower concentration areas thin out the most. As far as northward extent of open water, and you can see a lot of open water ranging throughout the Arctic right now. The furthest northward extents are in the region near the Laptev Sea, near the central Arctic Ocean, ranging about as high as 81, maybe 82 degrees north latitude, and a rather far northward invasion of ice melt in the region east of Svalbard, as well as running in through the Greenland Strait, with the ice export zone, the typical ice export zone, mostly devoid of ice as well. Looking over at the Canadian archipelago, we can see that the fabled Northwest Passage is open. It's been open for a number of days now, as is the Northeast Passage. So greatly reduced Arctic sea ice extents. Now, looking at the National Snow and Ice Data Center monitor, their Chartic graph, we find that Arctic sea ice extent for the day is second lowest on record, just running about 99,000 square kilometers shy of the record low that was produced for the day back in 2012. Looking at this map, we can see that long periods of time occurred during 2019 when Arctic sea ice extent for 2019, as seen here by the blue line, was below 2012 Arctic sea ice extent, which was a record low year during the end of melt season and record low during much of the summertime. Another year in which Arctic sea ice was rather low during the middle part of the summer was 2011. And we see that 2019 competes with 2011 and 2012 for much of the middle portion of the melt season, occurring in late June through the late July timeframe. But during 2019, record lows began in mid to late July, and extended in through early August. At present, we're just above record lows set in 2012. And given the present trajectory, it does look like 2019 is likely to at least be second or third lowest on record by the end of melt season, with the potential for it being first lowest on record. But 2012 was a very severe year for Arctic sea ice melt, so it's a bit less likely that we will tend to see a new all-time record low at the end of melt season broken. But considering the present state of the Arctic, I wouldn't rule it out. I think it would be ill-advised to rule it out. Now, just looking at this sea ice compared to periods of time, decadal periods of time, I'm just going to go ahead and highlight the averages for the periods of 1979 to 1990 in the orange here. And you can see how much lower Arctic sea ice extent is than these earlier periods, running in through the 2000s, which is noted by, 1990s, noted by the green line here, still much lower than decadal averages for the 1990s. And then running in through the 2000s, which is the black line, we're still many hundreds of thousands of square kilometers below typical ice extents, Arctic sea ice extents for this time of year. And even in present decades, which have seen some very serious Arctic sea ice losses, represented by this lighter blue line here, kind of close to the 2011 green line, which appears to have charted out a pretty average progression, 2011, for the decade of the 2010s. We see we are also still much, much lower. And you can look at this decadal progression and see how much the sea ice has been hammered by the overall trend of global heating that we have seen. Now, looking at Greenland, which is another very large concentration of ice in the Arctic, and Greenland in particular is very relevant to global sea level rise. In total, Greenland represents about 23 feet of global sea level rise if all the ice were to melt. So So climate scientists and glaciologists and ocean observers and sea level watchers are all very concerned about what happens to the Greenland ice sheet. Now, I've highlighted the record surface area melt year of 2012 as a comparison with 2019. And what we are seeing as far as surface melt extent goes is that we're getting into years now where the 2012 record is starting to be challenged in a number of metrics, not just surface area, but also melt volume. And I'm going to talk a little bit about melt volume as we go on. But looking at this graph, provided by the National Snow and Ice Data Center, you can see that 2012 is still the king when it comes to total surface area melt. But 2019 and 2012 is indicated in the orange, 2019 indicated in the blue, does show some periods where surface melt exceeded or challenged the 2012 extent figures. And you can see this very large melt spike in particular during late July and early August. And it is during this very large surface melt spike in which about 60% of the ice sheet saw surface melt that, according to recent reports, we have seen record surface melt volume. Now, there's a difference between extent, which is how much of the surface area sees melt on Greenland, and net volume of loss. So you can have, apparently, periods of time when surface melt extent is not quite so large, but the volume of water in the form of melted ice coming off the ice sheet exceeds past records. And this is what happened during late July and early August of this year during the record global heating episodes. And I'm just going to cite the Smithsonian in its statement of a record single day of surface volume ice loss of 12.5 billion tons in a single day. And I'm just going to go ahead and read a couple of quotes from this article. Last Thursday, on August 1st, the Greenland ice sheet experienced its largest single-day volume loss on record, sending an estimated 2.5 billion tons of ice pouring into the ocean. And I'm just going to go ahead and skip ahead and note some statements from some experts and from some climate reporters. As Andrew Freeman and Jason Samenow report for the Washington Post, Thursday's melting event outpaced all data collection since 1950, when scientists first started tracking the ice sheet's daily mass loss. So the daily mass loss record was an all-time record high volume loss for the Greenland ice sheet in early August. This outpaces 2012, and just to put it into context, 12.5 billion tons of ice is roughly equivalent to 12.5 cubic kilometers of meltwater volume. So imagine 12.5 moderate-sized mountains of ice, and that's basically what was lost from the Greenland ice sheet in just one single day. Enough ice loss to cover all of the state of Florida in 5 inches of water one day, all going into the world ocean system. So major loss. And one last visual that I'd like to show you is this account by Polar Portal, which shows mass loss day to day and mass gain. And as you can see, in the late July and early August timeframe, we saw some very severe loss in volume, well outside the regular range of standard deviation for Greenland. So very severe losses in ice, both in sea ice and in the form of loss of ice in the form of melt from the Greenland ice sheet. Now, finally, a final indicator of the very severe heat as a result of the global heating crisis driven by fossil fuel burning that I want to talk about is the present crisis of severe Arctic wildfires. And looking at the NASA Worldview map, we can see extraordinarily large hotspots and extraordinarily large extents of smoke coming from these wildfires in Siberia. And just looking at the satellite shot provides a very dramatic picture of the Arctic heating that we are seeing in 2019, which is part of the larger global trend of human-forced climate change and global heating, but also the larger trend of more rapid Arctic heating. And these smoke plumes just blow out from these massive fires. They get caught up in the upper level and mid-level air circulation. And in this case, the wildfire smoke is being pulled up over the pole. And you can see the plume here running up through this high amplitude jet stream wave, running up through the ice-free Laptev Ocean and into the northern polar region near the 90-degree north latitude zone. And you can also see the very broken and thinned ice flows of the Arctic Ocean as well in the stunning satellite shot provided by NASA. I'm just going to go ahead and zoom in on some of these fire clusters. These fire clusters are enormous. I'm just going to compare this to the lower corner. If you can see this in the right-hand corner, there's a little bar here that has a 50-mile extent, and you can see that the length of some of these fire clusters is ranging around 20 or even 30 miles. I'm going to go ahead and just zoom in a little closer so you can look at the dramatic and to me terrifying burn scars on the far northern zones. And we can click in here and see how far north these extraordinarily large Arctic wildfires are. This is in the 68.9 degree north latitude zone, so very close to the Arctic Ocean, a number of degrees in latitude above the Arctic Circle. And just moving here to the north, you can see that the Arctic Ocean is just right here. So extraordinarily large wildfires burning in northern Siberia through permafrost zones that have thawed and whose surfaces have thawed and provided these added fuels for the fire in this period of heat. And so what we're seeing is the heating Arctic providing a threat to the Arctic forests, to the northern forests, the boreal forests. And so in order to save these forests, which are a really critical aspect of the buffers to human-forced climate change, you really have to work very hard to try to limit the amount of human-forced climate change. And in order to do that, you really have to rapidly start reducing fossil fuel burning. And we really need to get on this. We need to really work hard to transition to clean energy, and optimistically, sources like solar and wind and electric vehicles are becoming much more available. And we should really not listen to the political forces that are trying to stop that transition. We should embrace it wholeheartedly, because the fires that we are seeing now are the early outliers, as bad as they look, to much worse fires to come if we keep burning fossil fuels. So I just want to look at some news reports related to these fires. And one of them is provided by the World Meteorological Organization. And this is a really stunning image provided by the World Meteorological Organization. I'm just going to go ahead and zoom in on it for you. And what it does is it maps out the extent of the smoke presently coming from the Arctic wildfires in Siberia. Now, this is an August 11th image projection, but it shows that approximately 5 million square kilometers is at present covered by smoke from these massive and tragic fires burning in the Arctic. And for context, according to the World Meteorological Organization, the European Union covers about 4.5 million square kilometers, and the contiguous US about 8.1 million square kilometers. So these fires in extent, as far as smoke plume coverage goes, are larger than the European Union as of August 11th. Now here's an image provided by Copernicus of one of the massive fires burning in the 70-degree north latitude region in the Arctic Circle zone. And this fire is very large. According to, I'm actually just going to pause here and look at the stunning graphic showing a very vivid burn scar and extraordinarily vivid fire line advancing into the Arctic forests and Arctic soils and Arctic tundra area. And according to Copernicus, this is in the 70.9 degree north latitude zone. It's about 60 kilometers from the shores of Sitkan Tala Bay in the Laptev Sea. And the burn scar coverage by itself for the single fire is 60 square kilometers. So a very massive fire burning in the Arctic. Now, it's also worth noting that Russia's TASS organization at present says that 4,500 firefighters and scores of aircraft are presently engaged in fighting the wildfires in the Arctic. This is essentially an army of firefighters. This seems to happen year after year, but in this particular instance for 2019, these fires have been very, very intense. So just to sum up, for 2019, we have had record hot Junes and Julys. We have seen record amounts of Arctic sea ice melt in the form of Arctic sea ice extent loss, and record amounts of Greenland melt in the form of ice volume loss from Greenland. We've seen a number of record temperatures broken in the Arctic zone, and these record hot temperatures have coincided with extraordinary wildfires, in many cases unprecedented wildfires, in the terms of lands burned and forests burned, as well as far northward extent of the fires. So an extreme impact to the Arctic during the summer of 2019 due to the massive global heating crisis driven by fossil fuel burning. Thank you for joining me for another climate change and clean energy blog, and I'll be chatting with you again soon.